All right, here we go with our next lesson. So today we're talking about scatterplots and lines of best fit. This is a little weird. It's a little different from stuff you've done before. At the same time, it's not. There's connections to previous lessons, which is very helpful. So a scatterplot's a graph, and this graph shows the relationship between two data sets, like the age of people and the number of pets they own, or like how much food you eat and how far you run, whatever. So this is graphed as ordered pairs in a coordinate plane, and there may or may not be a trend in the data. So scatter plots look something like this. I'm not going to label anything right now. I'm just going to show you how things look. So you have dots everywhere. So each of these dots is tied to numbers. So you have like your various numbers here, you get your various numbers here, and so on and so forth. So this particular scatter plot, this would be called a no correlation. And no correlation means that there's no connection between the data. It's not, one of them does not affect the other one. For example, this might be down here your height in inches. And over here this side is the number of pets you own. Your height does not affect the number of pets you own. Now, you could be 7 foot tall and have no pets. You could be 5'1" and have 19 pets. There's no pattern there. So scatter plots trying to find a pattern. So correlation is another fancy word for pattern. So in this case, there's no correlation, there's no pattern. So you see a scatter plot like this, there's no pattern, no correlation. Now a scatter plot looks like this. Notice how your points, as you go from left to right, the points are going up. Just like in slope, this is called a positive correlation. And this basically means it's going up from left to right. So we call this a linear correlation to be typical about it, but this is a positive correlation. And this one's actually called a strong positive. And it's called that because if you look at the points here, they're all kind of clustered together. You get a few outliers, like this one's kind of out on its own, doing its own thing. But for the most part, they're all kind of gathered very closely together. So that's why it's called a strong positive. And this one could be talking about something like maybe a baby's age in months and its height. So the older the baby gets, the taller it gets. That makes sense, right? You should be getting taller as you get older. Of course, some of you stop growing around age 6 or so, I think. But that's okay, it's fine. All right, so if that's a strong positive, this one's a weak positive. Notice how overall it's kind of going up and to the right, but it's a lot more spread out. So they would call this a weak positive. Because you can say overall, yeah, it's going up, but it's not like it's super duper strong and definite. This is going up, but not that great. Now the other direction would be the negatives. So you'd have something like this. That's a strong negative correlation. And that just means it's going down from left to right. It's just like a slope. It's a negative slope. Doesn't mean it's a bad thing. Don't think of it as like good and bad, just going in a negative direction. Like this could be number of months. This could be your car's value. Most cars, as they go on, get older, they're worth less and less money. And then a weak negative correlation will look kind of like this. Again, overall, it's going down from left to right, but it's not that tightly packed together. So weak negative. So the one on the right here, this is kind of obvious. This is a negative correlation. And you could even say it's a strong negative. So the one on the left here, it looks at first like, oh, maybe it's going up. So a positive. But then if you look at it another direction, it looks like it's kind of going down, like a negative. Since it's not clear cut either direction, this is no correlation. All right, so let's see here. It says the scatter plot shows the amount X in grams of sugar and the numbers Y, which represents the calories in 10 different smoothies. So real quick here, see right here, this little tiny break looking thing here? That means that they put a huge gap in the graph. Like notice how they went from 0 to 46 and 0 to 240. So that little weird symbol there, little break thing, means there's a big gap here. That's all it means. Nothing fancy. Big gap. All right, so the first question says, how many calories in a smoothie that contains 56 grams of sugar? Well, 56 grams of sugar is right about here. So just go up. Oh, there it is, 270. So how many grams in a smoothie that has 320 calories? Well, 320 is right here. So we go over, and oh, look at there. There it is. So we can go down, and that is 70 grams. And the question is, what is happening to the number of calories as the number of grams of sugar increases? So look at your graph here, and they're kind of going up. So as your sugar increases, the calories increase. That's what I want you to say. All right, answer these two questions. So pause the video and then come back when you're done. All right, so your answers here. For the student who spends 6 hours a week on homework, the GPA, 6 hours is right about here. So 2.0. It goes over there. So 2.75 grade point average. And you know how long they spend on homework? 2.75 is right about here. So go over right there. And that would be 12. So what tends to happen? As you spend more hours doing homework, you get a higher grade point average. All right, next up is the weird part. It's been pretty easy, not that big of a deal, but this is a little strange. This was called line of best fit. Some books just call it line of fit. It depends on which textbook you're reading and which teacher you have. So what this is a line that you draw on a scatter plot and ideally it's close to most of the points. The lines of fit are usually not an exact fit. That's why it's called best fit. So with these things, here's where it gets weird. You might all have completely different answers based on where you put your line. And you could all be correct. Now, there are more correct answers. Now, it sounds kind of weird, but that's the case. So here's what it looks like. All right, get your graph here. You'd have numbers in the bottom, the top, so on and so forth. I'm going to skip that part for now. So if I got a bunch of points, like that, my goal is to draw a line that goes through the points and has basically the same number of points above as below. So you kind of want to go through the middle of the data set. So when I draw a line of best fit here, it would look something like this. If you look at it, you got roughly the same number of points above and below. There's like 4, 8 there, and there's like 3, 6, 10 there. You're not going to have an exact number on top and bottom. It's not going to happen. But overall, this line basically cuts it in half and kind of fits the data. That's why it's called a line of best fit. Now, if I had drawn something like this, let me just redo this. If I put a line like this, most of the points are below the line. That's not the best fit. That line's a little too far off. That's what I mean by there's degrees of correctness. This would be wrong. And so would this. I put a line over here and go, look at that. All the points are above the line. It's not accurate. And even something like this, and you go through like that, it's not exactly balanced. You're trying to find the best balance you can. And it's going to be tricky. It's not an easy, obvious thing usually. Close enough. So your line may go through points and it may not. Ideally it will, because that's how it wants you to write the equation of the line. Yes, you have to write the equation of the line of best fit. Isn't that awesome? I know you're excited. Or not. I don't know. I can't tell. I can't see you right now. All right, so here you have the table shows the numbers Y in millions of subscribers to a video sharing website, X years after 2010. They want you to write an equation that models this thing and then interpret the slope y-intercept. So over here on the left-hand side, I went ahead and just did the graph already. Actually, I took it from your textbook. I just copied and pasted, which is awesome. And so that's your line of best fit. That's how your graph would go. Like over here, you have subscribers in millions because you don't want to try to graph 10 million and 20 million. So we graph 10, 20, 30, 40. We specify on the graph, this is millions. On the bottom is the number of years since 2010. So 1 year, 2 year, so on and so forth. Now, to write your equation, your line of best fit, they say you try to find 2 points on the line. And by a happy coincidence, they made sure we had 2 points on the line. Isn't that nice of them? And now it's just the same thing you've been doing the last couple of weeks. You have 2 points, write your equation. So find your slope. So your slope is 10. Let's plug it into an equation, get a slope-intercept form. So y, I'll say minus 26 equals 10, x minus 2. So y minus 26 equals 10x minus 20. So y equals 10x plus 6. So now you have to interpret this and what that means. So what this roughly means here, your slope is your change. So this means that you're getting roughly, you're gaining about 10 million each year. Now your y-intercept, or 6, that means you started around 6 million. So that's how you interpret it. The slope is the change. So you just have to know, you look at your graph, you're saying up and over, so I'm going up 10 million over 1 year. So 10 million per year. And the intercept, that was year 0, so that's where we started. All right, so now this one says your table shows your number y in thousands of cars sold for a particular model each year for X years since 2014. So they want you to write the equation that models number of cars sold as a function of the number of years. So on the right-hand side here, I graphed it for you, because I'm generous. And we found 2 points. So go ahead and write the equation of that line, and then tell me what the slope and y-intercept mean. So go ahead and pause. I'll be here when you're done. All right, so let's go ahead and find our slope. So 162 minus 63 over 0 minus 3. So that's 99 over negative 3, which is negative 33. So let's pick a point and plug things in. I'm going to use 0, 162 because it has a 0. That means it's easier to work with. So y minus 162 equals negative 33, x minus 0. So y minus 162 equals negative 33x. The 0 just goes away. So y equals negative 33x plus 162. That's the equation you got. So what does that translate to? Well, your slope is negative 33. And what that means is the number of cars sold decreased by 33,000 each year. And if you're not sure what words to use, look what your graph says. So over here is number of cars sold, and over here is number of years. So that's what word you're using. Okay, so now the y-intercept. What does the y-intercept mean? That means at the beginning, so in 2014, you started with 162,000 cars. Remember that graph said number of cars in the thousands, so these numbers are in the thousands. And that's what it means. So it's not as painful as it seems. I know it feels kind of bad, but it's not that bad. So your work, which you can do in class or right now if you want to, is the 4.5 practice. Numbers 1 through 10 and 15. Now, our next video, we're going to cover 2 lessons in one. They're weird, just to warn you ahead of time, but not that bad.